This video is using the quadratic formula. And the quadratic formula is used when you have a quadratic equation on the standard form. So to find solutions to ax squared plus bx plus c equals 0, we can use the quadratic formula. And the quadratic formula is a way of solving this for x, right? So a, b, and c are going to be real numbers. The x's are going to stay x's. You need to have an x squared in there. That's what tells you it's a quadratic equation. You need to have one side equal to 0. That's what allows you to use this formula. So we're solving for x. We end up with x equals, and the formula says we have negative b plus or minus the square root of b squared minus 4ac. That entire thing is over a denominator of 2a. So that's how you find solutions. Now, a lot of times when you have something in this form, you'll be able to factor it. And if you can factor it, you probably should do that first. You could also complete the square. That's another method people use. Quadratic formula is handy because it'll always work, but it's not as efficient in terms of time. If you're to factor this or complete the square, sometimes that's easier. So we're just going to look at an example or two just to make sure we understand how to use the formula. So if I said to solve, and I had 5x squared minus 2x equals 4. So first off, I know I have a quadratic equation because the highest power I see is 2 on my variable. To use the quadratic formula, I first need to get it in standard form. And actually, you would need to do that if you were factoring anyway. So the first thing I'm going to do is subtract 4 from each side so I can get the one side to be 0. Doing that leaves me with 5x squared minus 2x minus 4, writing it in descending order, equals 0. Make sure you still have equals 0. You need that. Keeps it an equation. Once you're here, you could try factoring. We're going to use quadratic formula. I don't think factoring is going to help us much here. Using quadratic formula, we have it right above. You know, sometimes I like to write what a, b, and c are just so I can keep track of them. So if we're looking at this, right, in this form right here, we want to pick out a, b, and c because we have to use from the standard form. So a is equal to 5, b is equal to negative 2, it's the coefficient of x, and c equals negative 4, it's the constant term. And we're going to substitute those into our quadratic formula that we see above. So make sure you write x equals because it's the solution. So x equals negative b, so it's going to be negative, and then b was negative 2, so it's a negative negative 2, plus or minus the square root of b squared. Now b was negative 2, so make sure you put negative 2 in parentheses, that whole quantity getting squared, minus 4 times a in this case was 5, times c in this case is negative 4. Make sure you know this is all being multiplied for that 4ac, so you just multiply them all together. And this is all over 2 times a, so this is over 2 times 5. Once you have this, we simplify. So we end up with x equals negative negative 2 is negative 1 times negative 2, which makes it just a positive 2, plus or minus the square root of, let's talk about what happens in here. A negative 2, that quantity square gives you a positive 4. A negative 4 times 5 times negative 4. The sign on this, a negative times a positive, will still be negative times a negative will make it positive, so this is going to be a plus now. It gives you an operation. 4 times 5 times 4. 4 times 5 is 20, times 4 is 80, so it's a plus 80. And this is all over 2 times 5, which is 10. Simplifying this further, we have x equals 2 plus or minus the square root of 4 plus 80. You have to do first. You can't just try to take the square root of 4 and the square root of 80. If there's addition inside of that square root, you have to add those together before you can take the square root. So 2 plus or minus the square root of 84 all over 10. And let's simplify this further. This is 2 plus or minus. Remember how you simplify the square root of a non-perfect square? So 84 is not a perfect square, so we can't just evaluate it immediately. The square root of 84, you want the highest perfect square as a factor of 84 times a non-perfect square factor. In this case, the square root of 84 breaks down to the square root of 4, that's the perfect square factor, times the square root of 21, that's the non-perfect square factor, all over 10. So this would be equal to 2 plus or minus square root of 4 is 2, square root of 21 all over 10. And we'll simplify this. Just a couple things to point out. You just can't cancel the 2 and the 10 here or here or here. You can't just cancel those out. Once you're here, you might look at it like, oh, I can cancel the 2 from both of these and the 10. I would be very careful about how you approach it. What I would more likely do is factor out GCF from the numerator. So I'll factor out a GCF of 2. So I'm left with 1 plus or minus, this is 1 square root of 21, or just square root of 21, all over 10. And then to simplify this, now that I have some things that are being multiplied in the numerator, now I'm allowed to cancel with that denominator because these are individual factors now. So if I cancel a 2 here with the 10, this really just becomes a 1. 10 divided by 2 gives me a 5. So I end up with 1 plus or minus the square root of 21 all over 5. Now, that's what x equals, right? That was our answer. But keep in mind, this is 2 answers, right? The 2 answers, just so you know, are 1 plus the square root of 21 over 5, and x equals 1 minus the square root of 21 over 5. So this plus or minus is really just a shorthand notation way of writing. We have 2 answers, and the only difference is in the first one you're adding in the numerator, the second one you're subtracting in the numerator. These are exact values. In other words, I left them in terms of the square root. They're simplified because I simplified the radical. But if you were to, do this and give me a decimal number, you're not being exact because you're showing, you would be approximating the square root of the 21 that's in there when you give me a decimal answer. So it's 2 answers. Make sure you understand it's 2 answers. You can answer it as, one that's combined with the plus or minus, but have an understanding of what that really means. We'll take a look at one more here. So if I asked you to solve this one, if I said solve 3x squared minus 6x plus 4 equals 0. So it's already in the standard form, which is nice. You could try to factor it. I don't think it's going to get us very far in this case. So if you can't factor it, you should try using the quadratic formula. Let's just go over what a, b, and c are. A in this case is equal to 3. It's the coefficient of the x squared. B is the coefficient of x, so it's negative 6. And c is a positive 4. And using the formula, right, it's x equals, and you should memorize the formula. So we'll do it out loud. It's negative b, so it's negative 6 plus or minus the square root of b squared, so b is negative 6, so it's negative 6 squared, minus 4ac, so it's 4 times a, which is 3, times c, which is 4, and this is all over 2 times a. Make sure you have that whole thing over this 2 times a, so it's 2 times 3. Once I have that, we will simplify it. So we have x equals a negative times a negative 6 makes that a positive 6, plus or minus the square root of negative 6, the quantity squared is a positive 36, minus 4 times 3 times 4, it's going to be negative, so it's subtraction. 4 times 3 times 4, 4 times 3 is 12, times 4 gives me 48. It's all over 2 times 3, which is 6. And then we'll simplify this further. We get x equals 6 plus or minus the square root of 36 minus 48. That's going to be a negative 12 all over 6. So let's stop for a minute here and just acknowledge a couple things. First off, you can't just cancel these 6's out. Sometimes people do that. You're not allowed to do it because there's a plus or minus here in between them. In other words, you have more than one term in the numerator. It's not factored out, so you can't cancel it. The second thing to acknowledge is that you want to simplify this square root here. The square root has a negative inside of it, right? So a negative inside of the radical gives us imaginary solutions. Now I still want you to solve this with the imaginary solutions. If it was something that you're looking at on a graph, this would just tell you that you have no real solutions. But because we're just trying to solve this, we'll take a look to see what kind of answers we get. Understanding that when you have the square root of a negative, right, the square root of -1 is equal to I, so you can always factor an I out of there. So really you could write this as 6 plus or minus I times the square root of 12 all over 6, just to show you how the I gets taken out because the square root of -1. So you're factoring that as an I representing the imaginary constant. Once I do that, now I want to simplify square root of 12 if I can, down to perfect square factors and non-perfect square factors. Well, this gives us 6 plus or minus I. The square root of 12, the highest perfect square factor of 12, well, that's 4 times the square root of 3 all over 6. So this ends up equaling, the square root of 4 is 2, so this ends up being 6 plus or minus 2I radical 3. Most often when we simplify this, we'll put the actual values that are constants in terms of numbers in front of the I. So 2I radical 3 all over 6. And now be very careful here. You can't just cancel the 6 and the 6, the 2 and the 6. You can't cancel amongst itself. I would factor this GCF out of the numerator of 2. If I factor 2 out of there, I'm left with 6 becomes 6 factoring out the 2 is 3, plus or minus 2I root 3 factoring out the 2 just gives me plus or minus I radical 3. It's all over 6. Now I'm allowed to cancel this 2 with this 6 as a common factor because these are being multiplied up here. So you're allowed to cancel things that are being multiplied with things that are being divided. So 2 divided by 6, right? So 2 reduces, 2 divided by 2 gives me 1. 6 divided by 2 gives me a 3. So it's really like 1 times this, so it's 3 plus or minus I radical 3 all over 3. It's an imaginary solution. This is x equals. These are the x values that would make the original problem true. And keeping in mind, there are two answers here, right? It's 3 plus I radical 3 over 3, 3 minus I radical 3 over 3. You cannot cancel these 3's here. You can't cancel a 3 from under the radical either because that is not a factor of 3. It's a factor of radical 3. So just be careful with the canceling. That's usually where people make mistakes. Usually the formula part's okay. But hopefully this helped refresh quadratic formula.